just me. All right. Oh, it's 2:02. Let's get this show on the road so we can get out of here. All right. Naming. We've done all sorts of stuff. We did ionic compounds. We've done molecular compounds. We've done acids yesterday. I don't generally bring up bases in case anyone was wondering, because for the most part, bases are metal hydroxides, which is just any metal, whether it's a main group or transition metal with an OH, the hydroxide polyatomic ions, you name them. Well, it's sodium hydroxide and potassium hydroxide and iron 3 hydroxide. It's the same. So to me, it's not an extra thing. There's no point in doing a day on naming bases. So we did acid names and formulas. If the anion ends in "ide," we put hydro and ic. So hydrochloric, hydrobromic, hydrofluoric, hydrocyanic, yada, yada, yada. If it ends in "ate," it becomes ic acid. So nitrate becomes nitric acid. Sounds like people are yelling upstairs. Hopefully Ben's not in too much trouble. If it's an ite, it becomes an us. So nitrite becomes nitrous acid. And we did those. And writing the formula, the name tells you what the anion is. So hydriotic. Well, I've got a hydro, and ic means I need iodide, which is I minus, and I add an H. Acetic is vinegar, or acetate. Carbonate, phosphite from phosphorus. We'll talk about that summary bit in a minute. And I posted these in there. I mean, if you go through, there's not a whole lot different than anything that we have done. HNO3. Some of these are a little bit different because, well, you just have to pull up your periodic table. But other than that, it's nothing out of the ordinary. Is there any questions on those? To the 10 of you. Jaden's not here. Isn't she normally here? Ryan kind of bailed. He used to be here all the time. So those are our acids and the names. Perchloric acid is a special one. Well, I guess later on we'll talk about electrolytes and strong and weak acids. There's 1, 2, 3, 4, 5, 6 common strong acids, which, well, just for perchloric acid is strong, but it's very rare because perchloric acid in and of itself is not stable in water. If you take that and mix it with water, it tends to become explosive. So you have solutions of perchloric acid in what's called glacial acetic acid, which is basically pure acetic acid. Vinegar is like 5%. Glacial acetic acid is more than 99%. So it's kind of a fun one to use. Hydrochloric is a strong acid. Sulfuric is a strong acid. Hydriotic. Nitric. That's what, 1, 2, 3, 4, 5. Oh, hydrobromic. Those are all strong quote unquote acids, and there's other ones that get more specialized. But that's naming acids. Now we have two things. So the summary is about what we've done. Well, we've looked at the periodic table. The periodic table is grouped by properties. Metals make cations, so anything with a metal is going to be ionic. No questions asked unless it's an acid with like permanganate or chromate. Uh, for ionic compounds, there's two types. There's one with brackets and those without. what's in the bracket, this is a charge. Nonmetals together make, or nonmetals make anions. Without oxygens or ides, with, we can have that. Um, make all decisions. First, this is the kind of big thing. I guess I'll just do this. Determine what type of compound. Based on what type of compound, you can get, um, you follow one of the three sets of rules. So I have here an acid has an H. A metal is ionic. No H, no metal is molecular. Molecular get prefixes. Roman numeral is in how many. And that's what, if we go down here, these for names and formulas are kind of flow charts that the book has devised. Um, it's kind of the thought process that I would use. So this sort of thing, you're given, whoops, I need a pen, given a formula. The first thing, if it starts with H, we go straight to acids. That's the first thing. If I'm looking at practice 7 or 8, I'm going through the formulas and looking for the H's because that tells me it's an acid. I use those rules, do those on their own. And then it says greater than 2 elements. So that means 3 or more. If it has more than 2, it's going to be a polyatomic ion. And the naming one is the tricky one. This is kind of polyatomic ion. It's going to be a metal, whether it's um, a regular one or a transition metal. Like these two branches fundamentally are similar. I personally look for the ones that have no metals because then I get, if it has no metal, it has to be molecular, and we go to prefixes. And then I go to the two ionic ones and have to justify, do I need a Roman numeral or not, based on polyatomic ions. But that's one possible flowchart to follow. Um, writing formulas. This one contains prefixes is the first thing to look for, even though this one ignores acids, which I'll mention here in a second. Prefixes are the easiest ones to, well, one of the easiest ones to figure out. If it has prefixes, it's molecular. You just, well, die this, try that, go for it. If it doesn't have prefixes, I personally look for Roman numerals because that tells us charges. And then we have the polyatomic ions in the main groups. And you've got to balance the charges, ignore whoever crisscross is evil and awful. Parentheses for why are acids left out? Well, acids are the easiest thing to identify. Acids have acid in the name. So if you know that it says that, then we have to use the acid rule. So 7 and 8 are oh, fundamentally the same thing. It's just I can't. I went through. I had done them. I cleared the ink. So if I'm looking for a formula, or well, to write a name, sorry, the first thing I would name is all the acids because they stick out with an H. No H, no H, no H. No, oh, that's got an H. That has to be an acid. I'm not going to go through everything because there's 25 of them. So I would go through, if I say just do the first 10, that's the only one that has an acid. So I know this is going to and in an acid. SO3 comes from our periodic table. This is sulfite. So ite, if we go back and look at the rules, changes to us, and we're done. So that's personally my first thing. Let's see, what did I put down the last time? Ionic. Oh, okay. Ionic, so look for... Oh, let's change the color for fun. Ionic, A group, and transition metals. So, well, sodium is a metal. That's got a whole bunch of stuff, so that's got to be ionic. That's got a whole bunch of stuff, so that's got to be ionic. That's a metal. Cobalt is a metal. When you're doing these, the periodic table should be handy. Now, I've said this for a whole bunch of stuff. This is how, as someone who's not super comfortable with naming, this is the easiest way to go through. I've filled this page in dozens of times, so I'm okay with it. So those are ionic. Sodium is an A group. That's ammonium, A group, A group. Oh, this is a transition metal. And of those, so that's a transition metal, so I can worry about that later. So Na is sodium as it is. Name the ions. My lord. I think Brittany is making bad run back and forth across the house, which Kate is sleeping, so it might not be the best time for that, but ammonium, polyatomics ion group, phosphate.
Is this naming in the assignment too, Friday?
The only thing that's in the Friday thing is ionic compounds. I'm going to put one up tomorrow, hopefully, that has kind of the three types and then a mixture, and then use that as the second one. So, but I will put all of this up. Like I have these two answered, so when I post this, I'm going to post it with answers so you can check, because that's kind of the idea. Barium is not a transition metal, so I'm going to name the ones without them. NO3 is that table, and so I've got all of the ionics named except for this one. So now we need to know that Cr2O7, it's something called dichromate. It is -2. If the dichromate is -2, the cobalt has to be, there's only one of them, +2. So there's my ionic compounds, and it's the same logical steps. 3 molecular, which should be, if you've identified all of the acids, then all of the ionic compounds. The molecular should be all that's left, and those are just prefixes. Carbon, tetrachloride, CHLORide, because, oh, apparently I skipped over that one. Sorry. Because sodium is a metal. Sodium. That's probably a pretty orange color because potassium dichromate is orange. So wrong color. Sorry. Molecular. These ones have to be molecular because those are our only type. Oh my gosh, that's xenon. Whatever. That exists. You can make it on your windowsill. Well, you can make it on a windowsill if you have xenon and fluorine gas, which most people don't, because xenon is expensive and fluorine is dangerous. And then SO2 is sulfur dioxide. So that's kind of the thought process for those. And you can do it in kind of whichever way works for you. If you are comfortable looking for the molecular compounds, do it that way. Like these are just the three categories. When it comes to writing a formula, I'm actually going to do this one as molecular compounds because these all, again, have prefixes. So just to do the first. Well, I see the first thing is tetra prefix, molecular. No prefix, no prefix, no prefix, no prefix. Hypo is not a prefix. Well, it kind of is. No, nope, nope, nope. So those are the molecular ones. Phosphorus, tetra, P4. Sulfide is S. Penta is 5. Dichlorine, so Cl2. Heptafluoride, F. That should be a 7, but my hand decided not to do 7 properly. So I'm doing those first. Uh, Personally, I'm doing acids next because those are the two that stick out. Acid. I don't know if there's any other ones. There's no other acid, so hypochlorous is going to come from hypochlorite, which is ClO minus 1. So I need 1H. Uh, and that's that one. So the rest now should be ionic. But in this case, I'm going to do this in 2 steps. Transition metal. Why am I doing transition metals? Because I'm looking for things if I'm writing a formula that stick out, that are different. Prefixes are different. The word acid is different. The Roman numerals stick out. So I'm going to do these. So this is going to be a transition metal. Transition metal. So those I know. Osmium is +3. Phosphate is not -1. Vanadium, and so osmium is OS. Phosphate is PO4. Vanadium is +4 in this case. Sulfate is -2. I need 2 sulfates for that. Well, potassium bromide. Tantalum, 5. +5, -1. TaCl5. Gallium. This set of stuff has a Roman numeral with gallium. Sometimes it's not there. If gallium doesn't have a Roman numeral, assume it's +3. So this is GaPO4. So that means we're going to be left with the A group ionics plus ammonium, which that probably doesn't look like it, but that's what it means. So I've got that one, that one, that one. I think those are it. So potassium bromide. Well, potassium is +1, -1, KBr. I'm pretty sure I know what that is, but that's one that I've got to look up. Sodium acetate. Sodium is +1. You can write it like that, or this is the one we talked about with acetic acid. With acetic acid, often you find the H at the end. In sodium acetate, you often find that at the end there. Nelson, I can't remember if stearate is up here. Benzoate is. Benzoate is. Oh, nuts. Come on. Why are you not? Okay, so that is a why stearate isn't there is a function of when they changed from that periodic table to a newer one. Ignore my reading NFL draft stories. Stearate is a polyatomic ion. It's a salt or acid of stearic acid. Okay, good. That doesn't really help me. Here we go. There it is. C17H35COO. Minus 1. Rubidium is plus 1, I think. I'm pretty sure. Now I'm doubting myself. This is awesome. Yeah. So this is RBC17H35. So it's got that COO bit that's similar to acetate, but instead of having a CH3, we've got this giant pile of stuff. Stearates or salt, whatever. Stearic acid. So stearic acid has an H. So that's when we talked about acetic acid, it stopped. Point to the screen because they can see that. Stearic acetic acid stops there. Stearic acid goes all the way down. It's a fatty acid. You can use it to make soaps, I think. Yeah. Beach tallow, waxy solid. As a food additive, soaps, lubricants. I have got to look. Niche uses. Mm, nothing as exciting as I thought. If you see the E570 is in some foods. I don't know what it does. It's a fat. It's not that big of a deal. So whether you, well, um, so that's my kind of process. When I say my process, but the logic behind how I would do all of this stuff. The more experience you get, some of you, because you've done naming in grade 10, could be super confident with this and just go, blah, 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 go all the way down right through. If that works for you, that's awesome. I might, is the next page. Oh, it is kind of color coded. Hmm. Um, I would suggest going through these. I'll put answers up and do some sort of. What is going on? I don't want to zoom to 120%. Um, that's still funny in the back. Um, that's kind of naming. I think we've been doing it for a week and a bit. I would suggest being able to try 7 and 8 if you can only finish 7 or only do 8. So be it. Some of you, I would assume, have them all done. I'm going to try today to go through those of you who've done the second assignment, um, just to kind of point out if there's anything. I'm going to put another one up that, oh, we got 7. That's all right. Apparently, I graded 3 of them. Hmm, cool. The things you know. Just in case there's, I don't think in the ones that I've looked at, there's been any huge issues. Um, but I will put another one up tomorrow or Thursday that has kind of everything. It would be
Are we on here tomorrow?
nope. But so like take 20 minutes to practice this, take 20 minutes to practice it tomorrow. I'll like the answers will be there so you can look them up. Um, because I'm not going to just do it with leaving no answers depending on how I'm probably just going to leave the ones that are in there because that's unless you want to try. I did post uh, files. Oh, it's part of the. Well, apparently I'm in math. Naming compounds package 2020. There are 2 pages at the end that, if you're a super nerd like me, now I don't know if I'm going to have time to do them this year. These came out of a book called the Hebden Problem Manual. Um, there's a couple typos, like there shouldn't be a hyphen in that phosphate, and some of them are simple, like iron is just Fe. Um, but I did those. It was an old textbook, no digital copy, so I typed all of that out last year because I was insane. Now that I think about it, naming and equating, yeah, we're in a decent spot. Um, so yeah, that's kind of if you want to try to do that, go for it. If not, don't worry about it. It's about being exposed. You've all done naming before, so I know that for a fact. So unless there's any questions, I will sign off and post the answers to all of those. And tomorrow or Thursday, post an assignment that has a little bit of everything. I mean, I can kind of show you what it's like, whether it'll be, it would be an H9 test. Structures. Yeah, none of you like take pictures and go Google these. I mean, there's no way I can check or anything. Like there was multiple choice with it. And I thought there. So basically, name the following. Write a formula for the following. Ionic, molecular. It's probably going to look almost exactly like this, even if it says points. Don't worry about it because, well, I'm not. I'll tell you which ones are wrong. I'm probably going to number them. Um, and there's a mixture that has, well, 10 of them, I guess. And that's how I would test this normally. I can't give you hundreds and thousands. So if that's everything, I'm done for the day unless anyone has any questions. Interesting. It if I can, that's freaky. I'm gonna have to stop that because it's gonna drive me nuts. So we good? As I babble and all of that. Uh-oh, I hear crying upstairs. Crap. So I'm done for the day. I'll see you guys tomorrow or Thursday. Sorry.
Where's your pen?
Bye. See ya.
Thank you.
You're welcome.